All right, today we're talking about something that could literally change how computers see the world. Meta just dropped its latest model, SAM-3. And folks, it's a massive leap forward for AI vision. So let's dive right in.
So to really get what's so cool about this, just think about this question. Older AI models, they were pretty good if you pointed at one bus and said, find this. But what if you wanted the AI to understand the idea, the whole concept of a yellow school bus and just find all of them everywhere in the shot, instantly? Well, that is exactly the problem SAM-3 was designed to crack.
And that leads us right into our first big idea here. We're talking about a leap from just pointing at stuff to an AI that actually understands visual concepts, kind of like how our own brains work. It's a move from pointing to real understanding. Now, this is where you can really see the difference. The old way, which the first SAM models were famous for, was called Promptable Visual Segmentation, or PVS. Simple. You point, it finds that one thing. The new way is Promptable Concept Segmentation, PCS. You just give it a concept like striped cat, and boom, it finds every single one. It's the difference between just seeing a thing and actually getting the idea of the thing.
So this new skill has a name, of course, Promptable Concept Segmentation. And listen, it's not just for still photos. SAM-3 can take a simple text prompt or even an example picture and use that to find, outline, and even track every matching object as it moves through a video. I mean, that is a huge upgrade in what these systems can do.
So how in the world did Meta actually pull this off? Let's take a look under the hood and check out the secret sauce behind this incredibly smart model. So the real magic trick here, it all comes down to this one brilliant idea, splitting up the what from the where. Instead of making one part of the AI do two really hard things at the same time, they just split the job. Two specialists for two different tasks. And this is a great way to think about it. First, you've got the presence head. Think of it like a scout. It does a quick scan of the image and just asks one question. Is the concept of dog even in this picture? If the scout says, yep, there's a dog here, then, and only then, does it call in the detector, which is basically the search party. The search party has one job: go find the exact location of every single dog. This separation makes the whole thing faster and way, way more accurate. Okay, but a model this smart, it needs a ton of really good data to learn from, right? So how do you get that much data and make sure it's high quality? Well, you build yourself an AI-powered data factory. And when I say a ton of data, I mean the scale is just mind-boggling. Get this, the new dataset they built to train SAM-3 has 4 million unique concept labels. That's a massive visual vocabulary for the AI. I mean, it covers pretty much anything you can think of. So how does this whole data factory actually work? It's a really smart loop. First, one AI takes a shot. It suggests concepts in an image and draws some rough outlines. Then a second AI comes in and acts like a quality checker. And here's the really clever part. Only the toughest cases, the ones the AIs aren't sure about, get passed on to human annotators. So the humans aren't doing the boring grunt work, they're the expert supervisors, fixing only the trickiest mistakes. Super efficient. And the result of all this? A huge, huge boost in efficiency. This teamwork between humans and AI, it more than doubles the speed of getting this data ready, compared to the old way of doing things. It's a smarter way to build a smarter AI. Okay, so the architecture is clever, the data is massive, but the big question is, does it actually work? Let's check out the performance numbers. And the answer is a big, fat yes. I mean, look at this. On the new test they built just for this kind of task, SAM-3 isn't just a little bit better, it literally doubles the accuracy of the best systems that came before it. That is not a small step forward. That's a giant leap. And to make sure they weren't just acing their own test, they threw it up against a standard industry benchmark. The result? A brand new state-of-the-art record. It jumped from an accuracy score of 38.5 all the way to 48.8. This proves it's not just good on its home turf. It can handle totally new concepts and images it's never seen before. And this is a really important point. SAM-3 isn't a one-trick pony. It's an upgrade across the board. It's also way better at the original stuff SAM-2 could do, like pointing at an object and having it perfectly outlined, especially when it comes to tracking things in a video. Okay, the tech is super impressive, but what does this actually mean for, the real world? Why should we care? Let's talk about what this could actually do. The possibilities here are, well, they're pretty wild. Think about a robot in a factory that doesn't need you to point to one screw. It can just find all the screws in a messy bin. Or what about AR glasses that could highlight every single bird you see on a walk in the park? For anyone creating content, imagine a tool that can select all the trees in a video so you can change their color instantly. And in science, it could speed up research by automatically identifying all the cancer cells on a microscope slide.
But the truly mind-bending part is what happens when you start combining these things. The researchers took it one step further and created something they call the SAM3 agent. They paired a powerful language model, the brains, with SAM3, the eyes. And when you put them together, you get something on a whole new level.
And the crazy part is, this SAM3 agent started doing complex visual reasoning, stuff it was never, ever trained to do. Like you could ask it to find the biggest animal that's kind of hidden behind a tree. The language model, the brain, figures out what that means and then tells Sam, the eyes, what to go look for. It's a real glimpse into a much more powerful general-purpose AI assistant. So all of this, it leaves us with one last really big question. For the first time, we've got an AI that's starting to see the world less like a computer and more like us. Not just pixels, but concepts. And as this technology gets better and better, we have to ask, what are we going to build? What new things will we discover? And what will we create together?